In this lesson, you'll learn about the geometry features in the Graphs application. Start a new document and insert a Graphs application. There are a few settings we need to set up for this session. Press Menu and select Settings. These settings are specific to the Graphs application. The first setting is Float. This is responsible for changing the quantity of digits displayed. For this session, Float 3 is good. Now tab down to Grid, arrow to the right and select Dot Grid. Tab down and select Automatically Label Points. And now press Enter to accept all the changes. We'll be working in Quadrant 1 only, so press Menu, select Windows Zoom and choose Quadrant 1. This will ensure that Quadrant 1 occupies most of the screen, but more importantly, that the viewing window is square, so circles will look like circles and right angles will appear as right angles. We're now ready to explore the problem. Press Menu, Geometry, Shapes, and select Triangle. Notice that the cursor changes to a pen. Move the pen over the origin. Click on the origin. This is the first vertex on our triangle. Now move to the right and up a little and place a vertex at a point close to 16,4. Don't worry if it's not all that accurate because we can change this later. Finally, move the pen to about 8,12 and click. Our triangle is now complete. Move the pen back over point C and press Ctrl followed by Menu. Select Coordinates and Equations. I need to move point C. With the hand over point C, I can just click and hold for a moment so the hand grabs the point. Now release the mouse pad a bit and just swipe to move point C until you get it at 8,12. Click to place the point and release the grip. Use these same steps to identify the coordinates of point B and then move point B to 16,4. Now it's time to do some construction work. Press Menu, Geometry, Construction, and select Perpendicular Bisector. Select side AB. The new straight line is at right angles to side AB and cuts it into two equal parts. Notice that our tool is still active, so we can go straight onto side BC and also onto side AC. It looks like the perpendicular bisectors meet at a single point. We can use the Geometry tool to explore. Press Menu, Geometry, Points and Lines, and select Intersection Point. Select two of the perpendicular bisectors, and point D is created. The Intersection tool is still active. Select another pair of bisectors, and point E is created. It looks like D and E are the same points. We can check to see if D and E are the same using algebra. We could calculate the gradient of each side of the triangle, use this to work out the gradient of the perpendicular line, locate midpoints, and therefore work out the equation to each perpendicular bisector. However, you may have noticed already from the contextual menu that the calculator can determine coordinates and equations. So, move the mouse over one of the perpendicular bisectors. Press Ctrl followed by Menu and select Coordinates and Equations. The perpendicular bisector of side BC has the equation y equals x minus 4. We can do the same to the other perpendicular bisectors and see that the perpendicular bisector of AB has the equation y equals negative 4x plus 34. And the last perpendicular bisector appears to be y equals negative 2/3 x plus 8 2/3. We can use simultaneous equations to see where the lines intersect. Insert a calculator application. I'll choose the shortcut Ctrl and I. We can solve the equations simultaneously. We have two equations. The variables are x and y, so we can just press Enter. Our first equation, y equals x minus 4. Tab down to the second equation, y equals negative 4x plus 34. And we see that the point of intersection is 38/5 and 18/5. Let's check another pair of equations. We get the same point of intersection, which means points D and E are actually the same. Now, there's something else that's interesting about this point. Let's check the distance from point D to each of the triangle's vertices. We can do this using the distance formula, which is the square root of 38/5 minus 16 all squared plus 18/5 minus 4 all squared. That's the distance from D to B. From D to C is the square root of 38/5 minus 8 all squared plus 18/5 minus 12 all squared, and we get the same answer. And of course the distance to the origin, same answer. So the distance from point D to each vertex is the same. So let's go back to the graphs application. That means we can draw a circle centered at D, passing through points A, B, and C, the vertices of the triangle. Now, our geometry construction in the graphs application is dynamic. So we can move any of the triangle's vertices, and the equations will update automatically, and see our circle continues to pass through all the vertices.